I had this banana
fun.
and I immediately lost it.
It is awful.
Mine's bad.
Angle towards me a little bit more then. Okay.
Good afternoon and welcome to everyone's favorite science segment of the day, the Physics Newscast at noon. I'm Miles.
And I'm Haley. A recent survey showed that wireless charging was the most anticipated feature of recent iPhone models.
The excitement doesn't end there.
Researchers in Cambridge are also exploring wireless charging
For electric vehicles, like Teslas.
So how does it work?
I am so glad you asked.
Wireless charging is actually based off a few simple physics principles.
Remember how Faraday figured out that a magnetic field can generate an electric current?
Yeah?
Well, in one of his experiments, he found out that it's actually the mechanical energy generated by moving a magnet that's converted into electricity.
Uh-huh.
When you move a magnet in and out of a loop of conducting wires, thanks to Lenz's law, the induced current in the wire generates a magnetic field opposite to the movement. That generates charge, which is measured in volts.
Thanks for the history lesson, but how does this apply to wireless charging?
There are two parts involved in wireless charging.
The transmitter, which would be your phone charger, and the receiver, your shiny new phone.
A copper loop antenna in the charger is used to create an oscillating magnetic field.
Okay.
Stay with me here. If the appropriate capacitance is added,
So the loops resonate at the same frequency, the magnetic field
will feed into the receiver in your phone.
charging it. Voila! This whole process is called resonant inductive charging or magnetic resonance.
Okay, so wireless charging transfers energy through electromagnetic induction, and the charger uses a coil to create an alternating electromagnetic field, which the receiver coil converts back into electricity?
Yeah, you got it.
What do people think about wireless charging?
Well, people have mixed opinions. To find out, I hit the street to see what people really think about wireless charging.
I just love it. It's like science fiction. The glass on the back of my phone just lets energy pass through. It's literally just magnetic induction.
Fascinating.
I don't even have to plug my phone in. I just set it down and it starts charging all by itself. It saves me a lot of time, and I keep one by my bed.
It's not even wireless charging because you still have to plug it into the wall, and you're giving these companies money that you don't need to spend, in my opinion. It's not as fast, it's slower than regular charging, and you can't use it when it's charging.
Really? You can't use it?
No, because your phone's like laying flat, so you can't use it, and it's not as energy efficient, and some of them overheat, so that's pretty dangerous.
Sadly, most people still find wireless charging impractical. But the tech-savvy are slowly taking the charging method out of obscurity. Who's to say what'll happen? Maybe it'll be lost to time as a late 20-teens trend, or maybe it's the future of convenience.
At least the physics was super cool.
Right.
One last question. Why can't you take electricity to a social outing?
Why?
Because it doesn't know how to conduct itself. Thanks for joining us on today's Physics Newscast at noon. I've been your host, Haley.
And I'm Miles.